All right, I'm going to give you a very quick tutorial on how to do a problem with scientific notation if your exponents or your power of 10 is not the same. We'll talk about if it's the same in class. That's pretty simple. You're probably not going to have any trouble with that. I don't think you'll have much trouble with multiplication or division. What I think you might have a little bit of problem with is when those two exponents are not the same. So what I'll do is I will show you the problem in a manner, kind of a more lengthy manner where we would actually deal with maybe more standard form or the numbers. But then I'm going to take you to the way that we'll actually do the problems. And I think when I do that, then that quicker way will make more sense to you. All right, so here we go. I'm going to give you a problem that, here's what it looks like. It's 1.4 times 10 to the negative second minus 2.6 times 10 to the negative third. Okay, what would that equal? Well, the very first thing is I'm very hopeful that you will understand that this scientific notation can be written as a value. Remember, scientific notation is a very important way to write numbers, especially numbers that are really cumbersome. Avogadro's number, 6.02 times 10 to the 23rd, is the number of representative particles in a mole of something. Who wants to write that value all the time? It's too cumbersome, it's too much. It's too much. So we use scientific notation. All right, so here we have, once again, we have two values, okay? These represent values, and we'll write those on the board here in a second. I also hope that you will recognize here in just a second, this value is bigger than this one, okay? Well, what do you mean? Well, here it is. 0.014 would be this written as a value. 0.0026 would be this written as a value. And remember, please, if you have a positive exponent, you're going to go this way with your, you're going to add zeros. If you have a negative exponent, you're going to move your decimal what? You're going to move it to the left. Do not be intimidated by positive and negative exponents. Okay, just remember that's going to, in large measure, it's going to determine direction. All right, just remember that when you're going to do addition or subtraction, that you have to have the same, multiple of 10. Okay, you have to have the same exponent. All right, so here's the value right here for this, and here's the value right here for this. Now, why am I showing you this? Well, it's simple. Because we can do the math if you'd like, and we could say 0.014 minus 0.0026. Okay, if we did, we can do that. We can do the math. All right. So if I do this math, then you're going to realize that obviously, come on, this is simple math. This is going to become a 3. This is going to become a 10. So 6 from 10 is 4. 2 from 3 is 1. 0 from 1 is 1, and 0 from 0 would be 0. Okay, what am I going to get? I'm going to get 0.0114. Now, but that's a value that's not written in scientific notation. Okay, I want to write it in scientific notation. So if I write this in scientific notation, okay, then I have to recognize two things. Two things that you are in the process, you're in the process of learning things, and you're in the process of building a spider web where you're putting different strands together. And I can't possibly teach you everything at once. So really, you're not going to see the whole spider web until it's done. But trust me, you will see the spider web. But if we're going to write this value that we've now derived, if we're going to write this in scientific notation, then the very first thing that we're going to have to remember is we're going to have to remember the definition of a coefficient. And if you recall, this is something that you should already know, but if you recall, it wasn't really, there was a slide in our notes, and it wasn't really words, it was this. It was 1, okay? It looked like this. Well, what does this mean? A is greater than or equal to 1, but less than 10. Now remember, what was A? A is the coefficient. Okay? And what is the coefficient? This and this is the coefficient, multiplied by 10 to a certain exponent. So if we're going to write this, okay, the same way we kind of did this, then the very first thing we have to remember, frankly, is we need to meet the definition of a coefficient. So the definition of a coefficient is greater than or equal to 1, but less than 10. So when we look at this, that gives us some direction as to how we're going to write this in scientific notation. That's the first thing. The second thing, okay, so this would be the first thing that we would consider right here. What would be the second item that we would consider? Well, the second item that we would consider is this has 2 sig figs. This has 2 sig figs. Okay? So how would we write this then? Well, we would write it as 1.1 times 10 to the negative second. Okay, now Mr. Day, why? Well, because we need to have 2 sig figs. We're certainly not going to write it as 11.4, because if we write it as 11.4, we're not meeting the definition of a coefficient. Think about that. So we're not going to write it as 11.4. We're also not even going to include the 4 because we have 2 sig figs. And so we want to have 2 sig figs here. Now the 0.4 is not big enough to cause us to round up. So we're going to write this as 1.1 times 10 to the negative second. So our answer at this juncture is this. Our answer is 1.1 times 10 to the negative second. Now, I'm hopeful that you will recognize this is the same as this. Okay? Now, why do I care? Well, I'll tell you why you care. Because I want you to see how we got here, okay, in a lengthier manner, or maybe using what we might call standard form, or by just like doing a lot of math, I guess you'd say. But this is not how we're going to do this problem. But you might want to kind of look at this and just imagine in your mind, okay, how did we get here? Okay? All right, so time out for just a second. So let's go back to the original problem, and let's do it the way we're going to do it, except now you're going to understand, I think, how it all comes together. So you're going to have 1.4 times 10 to the negative second minus 2.6 times 10 to the negative third equals what? Okay, remember when we were done a while ago and we got our answer, remember it was the same x 10 to the negative second, just like this. So we're going to create a little, I don't know if you want to call it a rule, a little hint, I don't know, a little way of doing business. And our way of doing business is we're going to look at our problem. So here you go, hint, hint. And what are we going to do? We're going to look at our larger measurement, because this number is bigger than this number, as you know. And we're going to change our multiple of 10, okay? We're going to change our multiple of 10 to the same multiple of 10 that we have in our larger number. So we're going to change basically to the larger number multiple of 10. That's going to be the process that we are going to adopt, okay? And you'll be able to see why here in just a second, all right? So here we go. So here's how we're going to do the problem. We're going to say, okay, so 1.4 times 10 to the negative second minus 0.26 times 10 to the negative second. Now, at this juncture, you may say, well, well, okay, look. If you take 0.26 and you move the decimal place 2 places to the left, you're going to have 0.0026, right? Well, that's the exact same thing you're going to have if you take 2.6, but you move it 3 places. It's the same value, 0.0026, okay? So I still have the same value, but I'm able to change my exponent so that my exponents are the same. Now, if I do the math right here, then I have 1.4 minus 0.26. Well, what do I get? I get a 3, make that a 10, that's a 4. What's 2 from 3? Well, it's 1. And what is 0 from 1? Well, it's 1. It's 1.14. So I'm going to drop my 4 because remember I only have 2 sig figs, right? And it's not enough to make it round, so it's going to be 1.1 times 10 to the negative second. Isn't that the same answer that I got before? And the answer is yes, that's the same answer that you got before. Okay? But this was a heck of a lot quicker because, quite frankly, I probably could have gotten by without even showing that step, right? I mean, that's pretty quick, but it's the same answer that I got before, but before I kind of showed you, it's like, you know, the total way to get there. Here, so I think if you're trying to take away main points, well, what's one of the main points that you're taking away? Well, one of the main points that you're taking away is that we simply changed. Which one did we change? Well, we changed the smaller to basically the larger, so to speak. And I'm not sure, maybe that's the greatest vernacular or wording in the world, but that's kind of the wording I'm going to use. We kind of changed from the smaller to the larger, okay? And then we just simply did the math. But we got the right answer by following the number of sig figs. All right? So that is how we will do a problem that involves integers that are not the same. Now, you might want to watch that a couple times. You might want to look at it. You might want to pause it, but you need to reason through that work. But the reason why I did it in a longer method the first time is so you could kind of conceptualize and just actually see how we got it. But then I think you should appreciate this particular way of doing it because you got the right answer, but quite frankly, you got there a whole lot quicker. Okay? Thank you.